Okay, so in question 3 we got a ball that is thrown horizontally. So this is a ball thrown horizontally from the top of a building. So this should be our building. Then it says that it lands a distance d from the foot of the building after having been in the air for time t. So we don't know the time. We only know that it's time t. And then encountering no significant air resistance. So let's write down what we have. No air resistance, time t. So we also don't know the distance. So it's going to be no values for t or d. So this is the distance, and this is a representation of the ball after it lands to the floor. So this is the height of the building, which is another unknown. So we have a couple unknowns. We got height, distance, time, those three things, unknowns. So then it says, if the building were twice as tall, the ball would have what? So let's draw the picture one more time. We're just gonna change the height, because it says if the building were twice as tall, that means that the height would be the double. So same representation, distance, and a little curve to represent the fall. So the equation that follows the y direction is y equal y initial plus velocity initial in regards in respect with y direction by the time plus at squared. But in this case, the a for this problem is going to be negative g, and we just bring down the t squared, 0. In this case, the y0 is the height. So let's put out h0 to h0. So continuing with the normal building with a normal height, the y0 will be h0. Now I just forgot the 1/2 in the equation. So let's rewrite it. The height minus 1/2 g t0 squared. So when y equals 0, t will be t0. So let's rewrite it. When y equals 0, ho or h0, sorry, minus 1/2 g t0 squared. So as we solve for t0, I'm gonna do the following. I'm gonna move this to the left side to make it positive. 1/2 g t0 squared equal h0. Now I'm gonna multiply 2 on both sides. We get rid of this one. We got g t squared 0 equal 2h0. Now we're gonna divide on both sides g, and we end up with t0 squared equal 2h0 divided by g. Next step, we're gonna square root of both sides. Cancel, t0 will be square root of 2h0 divided by g. So for a building with double the height, just use the same equation, y equals y0 plus initial velocity by the time plus at squared. Similarly, the y0 will represent the height, 2h0, and we also said that a was going to be negative gt squared. So if y equals 0, we get 0 equal 2h0 minus gt squared. Let's move it to the other side to make it positive. Gt squared being equal to 2h0 sorry, I forgot the 1/2 right here. The gt squared, there was a 1/2 in front, the coefficient. So it was negative 1/2. Now it's positive 1/2. So to solve for t, we get multiply both sides by 2, cancel, cancel. Then we're gonna divide both sides by g, cancel, cancel. We end up with t squared. So t squared will be equal to 4 times h0 divided by g. Or we can also rewrite this as 2 times 2h0 divided by g. So this is the same as g equal rad 2 2h0 g. But in this case, we know that we already found this out, and that was t0. So we can erase this and just write t0. So in that case, if the building were twice as tall, then the ball would have been in the air at time t rad 2.